Section 9.2, ANOVA for regression, video 7. There's two more small topics I'd like to discuss before we wrap up this section. One of them is called the standard deviation for the error. And the symbol for that is a lowercase s subscripted with a lowercase epsilon. Standard deviation for error. Makes perfect sense. What the standard deviation for error measures is how points in a scatter plot deviate from the regression line. So for example, if you have a line of best fit and most of the points hug the line pretty tightly, you should expect the standard deviation for the error to be relatively small. But if they're scattered all over the place, then you would expect this to be larger. In computer outputs, they'll often give you the standard deviation for error, but they'll often just denote it with a capital S. Now, if you're wondering why is this in the section for ANOVA for regression, it's because of the formula to calculate the standard deviation of errors. I'm not going to go into the derivation of the formula, but if you're curious, I'll refer you to page 597. But the formula for the standard deviation of errors is really simple. It's the square root of MSE. That's it. Why is it that? I refer you to page 597 for more details. So if you have ANOVA output, you'll have the MSE and you can calculate the standard deviation of errors directly. So for example, going back to the sugar versus calories model. What is wrong with me today? Sugar versus calories model. We could calculate the standard deviation of errors by simply taking the square root of MSE. And I believe the MSE was 15,000 something-ish. Yes, no, that was MS model, shame on me. The MS errors was 708. So we could put that in a calculator, we'll round it to a couple of decimal places because that's what the F statistic was rounded to. And the square root of 708 is 26.61. So it's a fairly easy calculation. We're not going to do much with the standard deviation of errors except use it as a piece of the next formula.